Hi everyone, welcome to the first session of data structure. As I was telling you during my Kickstart section, data structure plays a very important role. So as a budding engineer, and if you want to become a very good developer, data structure plays a very important role. Yes, so understanding the concept and implementing the concept is very important. So in this particular entire series of my video, I will try to make as much as possible to make the concept of data structure clear in a very simple way, and also I will be showing you the implementation in in C programming, and slowly other videos on implementing in C++ and also in Java will be introduced. So what do you understand by data structure? Okay, so we know that whenever we are doing program, so whenever we are doing program will be manipulating the data, right? So we will be always be handling the data, right? Okay, so we need to retrieve the data, we need to store the data. So whenever program manipulates the data, there has to be a certain proper way in which we should represent the data so that it helps us in manipulating the data very properly. So that's where data structure comes into picture. So data structure is mostly concerned with how you're representing the data, and that helps in manipulating the data in a more efficient way, right? Yes. So as I was telling, all programs represent data in some other way only, right? And data manipulations requires an algorithm also. So when we're talking about data manipulation, we requires an algorithm. So what is algorithm? I have already discussed in my series of what you will say in C programming. And however, in the next session also I will be discussing about the algorithm. You should go ahead and understand, because designing an efficient algorithm is very important, because an algorithm will going to is will use will going to manipulate and use the data, and as it is going to manipulate the data by algorithm, data are represented by numbers than data structure itself. So you can see there's a connectivity all of. So you need an algorithm to represent the logic need and manipulating the data itself. This particular algorithm will be implemented in some kind of programming language, right? And whenever we are talking about manipulation of data, data structures comes into picture, right? So you can understand the importance of all and of algorithm, program, and mostly the data structure in which the data is being represented and is being manipulated, right? So study of data structure is the fundamental to the computer programming. Yes. So as I said earlier, right? So we have understood that data structure is concerned with representing and manipulation of data, and all of us know that programs, okay, used to manipulate data. And whenever you are trying to represent certain logic and all, the most simple way we can do using an algorithm. An algorithm also manipulates the data, and hence the data structure is nothing but one of the most fundamental study in the computer programming. Okay, right? So basic data structure, there are two data structure we have classification: the linear structure and the non-linear structure. Okay, so under non-linear structure we have array, which is of fixed size. Then we have stack, we have queue, okay, and we have the priority queue. So stack, what is a stack? What is a queue? We're going to understand on the session of stack and queue. Just understand here the linear structure when you talk about, we are talking about array, we are talking about stack, we are talking about queue, we are talking about priority queue. So you can understand priority means you are giving, we are, we are trying to take somebody which is more prior than some other things. So that's where priority queue comes into the picture. And non-linear structure, we are talking about tree, we are talking about graph and all. So actually linear, when you talk about linear, is that it's something like when represented the data one after another itself in a sequence way. But whenever you talk about non-linear, it doesn't come in a in a proper sequence way. It can be some kind of hierarchy, or it can be distributed wise. So where we have the tree and the graph itself. Okay. So having said this, two aspect, linear structure and non-linear structure. Linear structure, array, stack, queue, and priority queue. Non-linear structure, tree and graph. Yes. So another way which we can distinguish, data structures in type of static and dynamic. When you talk about static, it is of fixed size. When you talk about static, it is of fixed size. When you talk about dynamic, it is not of fixed size, it is a variable size, and on time it will grow, it will sink. Okay, right? It will grow and sink. So static type example is array. So once you define an array, what is the number of element that will going to hold it? The number doesn't change, right? Because it is of fixed size, right? But whenever you talk about links, or when you talk about something like linked lists and all in data structure, okay, where we can grow, easily we can sync. So the size is never static, right? Based on the execution, okay, right? Yes, then that type of structure is called as dynamic structure. So static structure has a fixed size. An example is an array. Once you define, okay, the number of element that it can hold, it doesn't change. And dynamic structure, it will grow, it will sink, okay, at execution time as required by the content. And dynamic structures are implemented by links, so it will going to link one after another, and that will going to be clear when we will talk about linked list and all. So static and dynamic structure, I hope it is clear. Next come homogeneous and non-homogeneous. When you talk about homogeneous, it said all the elements are of same type. Say for example array. When you talk about m type, for example, we are only putting integer data, right? Then all elements will be integer only. Suppose we are saying all elements are float, it will be a float. All elements are character, it will be only character. So such kind of structure, data structure, is called as homogeneous data structure, and the best example is array. When you talk about non-homogeneous data set, the element can be of different type. We can have an integer, we can have a character, we can have a string, we can have an array also inside that. Okay, so such type of data structure are called as non-homogeneous, and usually the best example is the structure. Okay, right? Now come into the mind where exactly data structure are applied. So you can see a list like when you talk about compiler design, yes, data structure, operating system, yes, process management, memory management, or database management system, yes. You have the use of data structure itself, statistical analysis, numerical, graphics, AI, simulation, everywhere you can see the application of data structure, where data structure is extensively used. So let me summarize. So data structure is not about representation of data, how we are manipulating the data, and we can see programs manipulate data, right? And whenever you are representing logic in terms of algorithm also represents some data, right? So it is a fundamental, what do you say, fundamental course for all of us in order to understand data structure and how important it is, right? So data structure divided into two. One is a linear, another is a non-linear. We see linear as an array, stack, and queue. Non-linear as a tree and graph. When you talk about linear, we have a sequence, right? One after another, right? When you talk about non-linear, it is not in a linear way. Okay, we can have some kind of hierarchical ways of representing data like a tree and a graph itself. Then we have seen static and dynamic. When you talk about static, it is always fixed. When example is array. Once you give the size, you cannot change, right? When you talk about dynamic, yes, it can grow, it can shrink at the time of execution, right? So the size is never fixed. Then we have the homogeneous data. You have a non-homogeneous, data. Homogeneous of same type. Example array. So you have an array of integers, right? When you talk non-homogeneous, it can be of different type of data can be there. It can be integer, float, array, it can be strings and all. And a base example is structure. And you've seen that data structure is extensively used in compiler design, operating system, in database management system, statistical analysis, artificial intelligence, and simulation. So in this session, it is very clear that what is I hope what is data structure and how important is data structure, how important is understanding the concept of data structure, because if you want to really work with the right programs, so data structure plays a vital role. So having said this, thank you so much. So I hope in the next session we will be talking about the more aspects of data structure itself. Okay. So thank you so much.